Okay, in problem number 8, we have two functions, f of x and g of x, and they are differentiable. And we have some circumstances here, some constraints, and I always like to write my constraints out so I can see them. And notice here, they're not really in the way that I like to visualize them. I sort of like to look at things linearly and maybe sometimes vertically. So I'm going to write these out so they make them a little bit easier for me to see. So I know here that I have f of 4 is equal to a value of -3. I have g of 4, which is equal to a value of 2. F prime of 4 would be equal to a value of 4. And then I have g prime of 4, which is equal to a value of -1. So I like to look at it in terms of this. It makes it easier for me to see. So notice now I have to compute the following derivatives of the functions at x equals to 4. So we're going to have to find the derivative of these functions at x equals to 4. This is actually a question that involves taking the derivative of a function and then also a given stated function square root of x and another ubiquitous function, we can call this g of x. So when we do so, in this circumstance, we are going to have to find the derivative of this function, this composition of multiple functions, and then plug in when x is equal to 4. And the nice thing, notice each one of our values here are given in terms of when x equals to 4. So let us look at a comma 1 or a 1a or 1a, however you want to say it. When I take the derivative of f of x, I know that's just going to be f prime of x. And I'm going to keep my 4 out in front, and I'm going to have to take the square root, I'm going to have to take the derivative of x to the 1/2 times g of x. I'm going to have to take the derivative of these two functions. And notice I'm multiplying x to the 1/2, which is a function, and g of x, which I know is a differentiable function. So in order for me to take this derivative, I'm going to have to use a product rule. So I'm going to keep this f prime of x. I'm going to keep my -4 out in front. I will have my first function, x to the 1/2, times the derivative of my second, the derivative of g of x is just going to be g prime of x, plus my second function, which is g of x, times the derivative of my first, which will be 1/2 x to the -1/2 power. So I'm going to go ahead and clean this up ever so slightly. I'm going to keep my -4 out in front, but I'm going to have f prime of x minus 4. I'm going to transform this back to the square root of x because I like to look at it as such, times g prime of x plus g of x all over 2 times square root of x. So the 2 is on bottom. I brought the x to -1/2 back down to the denominator and transformed it back into square root of x. F prime of x is specific. We know that we're looking for this derivative when x is equal to 4. So notice here we're going to plug in a 4 everywhere we see an x. So here we're going to have square root of 4 times g prime of 4 plus g of 4 all over square root of 4. So in this circumstance, f prime of 4, I know that's equal to a value of 4. F prime of 4 equals to 4. So f prime of 4 minus 4 times square root of 4 is 2. G prime of 4 is -1. So all I'm doing is plugging in everywhere I see this, plus g of 4, which is equal to 2, all over square root of 4, which is 2, just like such. So this will equal to 4 minus 4 times the quantity of 2 times -1 is -2, plus 2 divided by 2, which is 1. This will give you 4 minus 4 times -2 plus 1 is -1. -4 times -1 is +4. 4 plus 4 is +8. So we figured out the first one. Again, this involved a little bit of product rule, a little bit of basic understanding of the way derivatives work. I know sometimes people get thrown off by these problems because they don't like the way they look. However, they tend to be really nice because we don't have to worry about any special methodology to take the derivative of functions. If we're given that f of x and g of x are differentiable, we know we don't have to worry about any special calculations because the derivative of f of x would just be f prime of x. The derivative of g of x is g prime of x. So now we can go on to A2. So a2, we have to find the derivative again. So we're going to go on to a2. And we have f of x over g of x plus 2 of x minus 8. So we have to find the derivative of f of x all over g of x plus, what was that, 2 of x? 2x minus 8. So in order for us to take the derivative of this guy, I hope we all recognize we're going to have to use a quotient rule. Quotient rule, we're going to take our denominator times the derivative of our numerator. The derivative of f of x will just be f prime of x minus our numerator, which is f of x, times the derivative of our denominator all over our denominator squared. So I've gone ahead and applied the quotient rule to this function, to this combination of functions. So I don't really want to go ahead and get too crazy, but I'm just going to go ahead and I'm going to simplify some steps. Taking the derivative of this guy, I hope we can recognize that we are going to have g prime of x plus 2, because we're taking the derivative of g of x, g prime of x. Derivative of 2x is just 2. Derivative of negative 8 is a value of 0. And we can now go ahead and plug in our value of 4, because that's really what we're looking for. So here we're going to have g of 4 plus 2 times 4 minus 8 times f prime of 4 minus f of 4 times g prime of 4 plus 2 all over g of 4 plus 2 times 4 minus 8 squared. Looking at this, g of 4, we know g of 4 is equal to a value of 2. So on top we're going to have 2. 2 times 4 is 8. 8 minus 8 is 0, so this just goes to 0. So we're going to have 2 times f prime of 4. F prime of 4 we know is equal to a value of 4. So I'm just plugging that in because that is what's given. Minus f of 4. F of 4 is negative 3. Negative 3 times g prime of 4. G prime of 4 is negative 1. Negative 1, which is going to be g prime of 4 plus 2 gives you value of 1. So we have value of 1 there. This is all over g of 4. I think we said g of 4 is equal to a value of 2. Plus 2 times 4 is 8. 8 minus 8 is 0, so this all goes to 0. So we're going to have 2 plus 0, quantity squared. 2 times 4 gives me a value of 8. Negative times a negative 3 gives you a value of positive 3. All over 2 squared, which is going to be a value of 4. 8 plus 3 is 11 all over 4. So our derivative at 4 is actually equal to 11/4. So hopefully we're working these through with me, or you're practicing them ahead of time just to make sure that we understand how this all works. I'm going to go ahead and I'm going to copy these little givens so I don't have to keep floating the page back up. So I'm going to copy that. I'm going to bring it down here so we can see it. Put it over here in my corner. So now we're going to take the derivative of f of x plus g of x plus x squared all to the third power. So we have to find the derivative of f of x plus g of x plus, what was that? I think x squared all to the third power. So we're going to have to take the derivative of this guy. So hopefully we recognize this is actually going to be a chain rule question. So we're going to bring our 3 down as a coefficient, and this is going to be 8, this is A3. So here we're going to have 3 times the inside. We are not going to change any values internal to this function, but we're going to reduce our exponent by a value of 1, but now we have to multiply times the derivative of the inside. Take the derivative of the inside, working our way left to right. Derivative of f of x is f prime of x. Derivative of g of x is g prime of x. Derivative of x squared is plus 2x. So I went ahead and I took the derivative of the inside because this, in fact, was just a chain rule question. This will give me 3 times f of 4. We're plugging in all the values of x we see. We're plugging in 4. Plus g of 4 plus 4 squared times f prime of 4 plus g prime of 4 plus 2 times 4. Let's keep going. Plugging this in now. F of 4 equals 2, negative 3. G of 4 is equal to positive 2 plus 4 squared gives you a value of 16. F prime of 4 is equal to a value of 4. G prime of 4 is equal to a value of negative 1 plus 2 times 4, which gives you a value of 8. Negative 3 plus 2 is negative 1. Negative 1 plus 16 is going to be 15. 4 minus 1 is 3, plus 8 is 11. Okay, so here we're going to have 3 times 15, which is 45, times 11. Let's go ahead and do 45 times 11. 5, 4, 5, 4, 5, 9, 4, which gives us a value of 495. So notice we were able to find this using our product rules, our quotient rules, and here we had to use our chain rule. And I know a lot of times maybe we looked at this problem initially, it was not something that we wanted to work with. However, we recognize here it's not so bad. I'd much rather work with this than having to work with very tedious, elaborate functions. So this brings us to the last portion of this question. It's part B. So we have a curve given by y equals x squared times f of x minus a times g of x plus 2x, where a is a parameter, also known as a constant. Compute the value of a such that the slope of the curve at x equals to 4 is 0. So we want to find where our derivative is equal to 0 when x equals to 4. Specifically, that will give us the point A. So I'm going to come down here, and I think I can bring my little set of givens down with me. So let's go ahead and look at this question. So we have part A, B. So we're going to have y equals to, also known as f of x, which will be x squared times f of x minus a times g of x plus 2x, where that is a parameter, a is a parameter. So we want to find the value of a. We're looking for a value of a, and we know one specific crucial circumstance, that the curve, the slope of the curve, so we know f prime of 4 is equal to 0. We know f prime of 4 is equal to 0. So let's go ahead and find this. We know that we're going to have f prime of x is equal to x squared. Oops, I'm sorry, I didn't take the derivative. We're going to have to do a product rule. So we're going to do a product rule. A product rule. So we have our product rule here. Excuse me. So I'm just going to look at this. So we'll look at this right here. We're going to have our first function, x squared, times the derivative of our second function, plus the second function times the derivative of our first. So we used the product rule. Our first function, x squared, derivative of our second, which will be just f prime, plus our second function, f of x, times the derivative of our first. A is just a constant. I'm going to keep this out. So we're going to have a, derivative of g of x will just be g prime of x, plus derivative of 2x is just going to be a value of 2. Plus 2 of x, derivative of x is just going to be a value of 2. So we know that f prime of 4 is specifically equal to 0. So we want to find the value of a such that the slope of the curve at x equals to 4 is 0. So this sometimes can be a little conflicting because you're saying, what happened? F prime of 4 is equal to 4. We're actually stating here, when I say f prime of 4, this is actually going to be the derivative y prime is equal to 0 when x is equal to 4. So be very careful about how this translates. When we say this problem has the derivative equal to a value of 0, when x equals to 4, or the slope of the tangent line is equal to 0, the slope of the curve is equal to 0 when x equals to 4, that's really saying that y prime is equal to 0. So here we're going to have 0 equals to x squared, plugging this in when a value is 4, I'm going to have 16 times f prime of x, but we're looking for f prime of 4. F prime of 4 is actually equal to 4. It is not 0. It's only going to be equal to 4, so we're going to have 4 plus f of 4. F of 4 is equal to negative 3 times 2 times negative 4. We're plugging in negative 4 here. Minus a times g prime of 4. G prime of 4 is equal to negative 1 still plus 2. So I've plugged in. Here I'll have 0. 16 times 4 is 64. Am I right? Yeah, that's 64. Negative 3 times 2 is negative 6. Times negative 4 is positive 24. Minus a gives you plus a plus 2. 64 plus 24 gives you a value of 88. Plus a plus 2. So we're going to have a value of 0 equals to 88 plus 2 is 90. Plus a, which implies that a is equal to negative 90. So we have the circumstance here that a is in fact equal to negative 90, and that is the only value that's going to suffice that criteria.